In 1905, Rutherford conducted an experiment wanting to prove the plum pudding model right. Rutherford bombarded alpha particles at a thin gold leaf, which was suspended in a vacuum and was surrounded by a fluorescent screen. The scientific community thought that the particles would pass straight through and could even puncture a hole. But what was observed shocked the entire world. There were three observations made by Rutherford and team. One, most of the particles went straight through. The next one was some of the particles deflected at angles greater than 4 degrees. And the last one was very few particles bounced back. From this, Rutherford concluded the fact that most of the particles went straight through concludes that the atom is mostly empty space. From the observation that few particles deflected at angles greater than 4 degrees, he concluded that the atoms have positively charged particles present inside the atom which repel the alpha particles. Lastly, from the fact that there were very few particles bounced back states that the mass and the positively charged particles are present in the same area. Since it was only a very small amount of particles, Rutherford concluded that the positive particles and the mass was present in a small dense sphere. He named this the nucleus. He also named the positively charged particles protons. This was named after Joseph Proust, who predicted the existence of these particles. He used gold because it was the only metal which could be pressed into very thin sheets without cracking. It was suspended in a vacuum because if any deflections were there, then it would be because of the atom and not the air particles. Lastly, alpha particles were a form of positively charged radioactive particles. The only thing that Rutherford couldn't explain was where the electrons were present. Due to this reason, people thought that he was wrong and didn't believe what he said.